Hey everybody, let's take a look at topic number two, operations of whole numbers. So before we do any add, subtract, multiply, and divide, I would like to talk about something called the properties of real numbers. So property of real numbers is going to be true for whole numbers, for integers, for fractions, and for decimals. Okay, so first thing, community property. Community property says for any real number A and B. Okay, so this number A and B are real number. They can be whole number, decimals, fractions. A plus B is the same as B plus A. What that really saying is when adding or multiplying, you can actually swap the order of the numbers. Okay, you can swap the order of the number. Why is that? It makes the computation a little bit easier. So here my example says 3 plus 14 is equal to 14 plus 3. So you can swap the order of your numbers. So a lot of times, if we have maybe I can use this same example. 3 plus 14, right? And what happens if I have plus a 7? Well, swapping the order allow you to say, okay, maybe I can keep the 3 and then just swap the order between 14 and 7. Maybe this will make it easier to add. So that will be 10 plus 14. Okay. Rather than here, most people will say 17 plus 7. So community property, same thing with multiplication too. It allows you to swap the order of your numbers when you multiply or add. Associative property says for any real number A, B, and C, if I got three numbers need to be added or three numbers need to be multiplied, we can choose to multiply or add any two numbers first, okay? And then add or multiply the third one. So when adding or multiplying, which two numbers you add or multiply first does not really matter. Okay, so for my example here you can say, all right, I'm going to do 13 plus 18 first, then plus 17, then plus 12. Or we can add 13 with the 17 first, then 18 with the 12 next. The order does not matter, okay? As long as you're adding or multiplying, which two you add, multiply, the order does not matter, okay? Identity property. So here's something a little bit different. Identity property says for addition, A for any real number A plus 0. Or you can say 0 plus that number. So maybe like 0 plus 2, or we can say 2 plus 0. The answer will always be the number itself, 2, or the A. So what they're telling you is 0 is the identity for addition. Okay? 0 plus anything is always going to be that number itself. 1 is the identity for multiplication. Any number times 1 is actually itself. So we can say A times 1 or 1 times A, which is still going to be the same number. Okay, this is very important because when we start talking about algebra, if you ever see an x, that x, for example, that x is literally means 1 times x. Okay, then the x literally means 1 times x. Okay, because any number is always times by 1. Any real number is always times by 1. So if you see a 2, that means 1 times 2, or you can say 2 times 1. Every number is always times by 1. So 1 is identity for multiplication. For inverse property for addition says if you have a number plus its inverse, okay, then the answer will always be 0. For example, if I take a 2 plus its inverse, which is negative 2, the answer will always be 0. So we say the number a and negative a, or here, my example, 2 and negative 2, are called the additive inverse. Okay? Now, the wording I normally use when this happens, I will say that number 2 and negative 2 are opposite to each other. Opposite means opposite signs. In algebra, when we say the word opposite sign. And the reason why I'm using the word opposite instead of inverse because I use the word inverse for multiplication. So for real number a, like for example 2, times its inverse, which is 1 over 2 or 1 over a, the answer will always be 1. So here we say a and 1 over a are inverse to each other. So I normally use the word inverse when it comes to multiplication. When it comes to addition, I will use the word opposite. Okay. So opposite means, just think about opposite means opposite signs. All right, let's take a look. All right, so here I give you some example. 2 plus negative 2 is 0. So addition, 2 and negative 2 are opposite to each other. 3 over 1 times 3 is equal to 1. So these two numbers, 3 over 1 and 3, are inverse to each other. So let's try this. Okay, identify the property that best describe the following. Okay, so when we're talking about, when we do an example like this, what you want to do is look at the order first, then or look at the community, then look at the associated property. So here on the left side, I got 11, I got 19, and 21. On the right hand side, I got 11, 19, and 21. So it's the same. The order has not been changed. What's changed between the two is the parenthesis. The parenthesis on the left side here indicates 19 and 21 will be added first. On the right, the parenthesis is on 11 and 19, so it means 11 and 19 will be added first. Okay, so which two you add does not matter. Since the order is the same, the only thing different is which two number I add. There's got to be associated property for addition. All right, same example right here. 11, 19, 21, 11, 21, then 19. So the order has been changed. So we know this is commutative property. But make sure the the numbers inside the parentheses are still the same. 19 plus 21, this is 21 plus 19. So these two numbers are still the same. The only thing different is the order has been swapped. Okay, so if I have an example like 11 plus 19 in the parentheses plus 21, 11 plus 21 plus 19. If I have an example like this one, that means it's both commutative and associative property because the order changed, and who I add first also changed. So this will be a good example for both. All right, let's quickly review our adding and subtracting. When add and subtract whole numbers, we need to line up the numbers by the place value. Okay, so earlier in the topic one, we're talking about expand the form. A number like 6,820 is really 6,000 plus 800 plus 20. So if you actually write out by the expanded form, the way how we add is we add them by the place value. Therefore, we need to line up these numbers vertically by their place value. So I'm just going to put 6820 on top, 7683 in the bottom. So let's kind of review this a little bit, get your mind start thinking about these operations. So 0 plus 3 is 3, 8 plus 2 is 10, so carry 1. I know I'm going to carry 1 on my finger. If you want, you can put a number on top or in the bottom, doesn't matter. I like to put on my finger because it's less number to look at. And whenever we carry into the next place, we never carry anything more than 10. So we should have enough fingers, for the carry. So this 8 plus 6 is 14. 14 plus 1 is 15. Carry 1 again. 6 plus 7 is 13 plus 1 is 14. So my answer, 14,503. All right, let's do another one. 123,654. 456, 282. All right, 6 plus 4 plus 2 is 6. 5 plus 8 is 13. Carry 1. This is 8, 9. This is 9, 7, and 5. 579,936. All right, subtracting. Remember now, if we don't have enough to subtract, we need to borrow. So make sure 5827. All right. So 4 is not enough to subtract 7, so we got to borrow 1 or borrow 10 from the 9. So that becomes 8. So when I borrow 10, we normally scratch off the 4 and write 14 up here. But when I borrow 10, we normally wrote 14 on top because we take the 10 plus the 4, then minus the 7. So that becomes 14 minus 7. So instead, I know I know, the properties of real number allows me to, add and subtract, add any two number first. So here I'm actually going to say I'm going to subtract 7 and 10 first. So instead of saying 14 minus 7, I'd have to say 10 minus 7 is 3 plus 4, which would give me 7. Okay, this is the way I do it. That's the way I grew up doing it. So if you want to say 14 minus 7 is 7, that's fine. All right, so 8 is enough to subtract 2, so that would be 6. 7 is not enough to subtract 8, so 7 got to borrow, so that becomes 6. So this becomes 5. So 10 minus, so you will say 16 minus 8. I will say 10 minus 8 plus 2, which is 8. Okay, either way, 867. 830,900, 749, oh, just gotta line it up. 74,985. All right, so the zero is not enough to subtract, so that zero got to borrow, so that'll be 10. This is gonna be 9. So we borrow all the way to 9. So that becomes 8. All right, don't keep on borrowing. Once we got enough, we need to go ahead and subtract. So 10 minus 5 is 5. 9 minus 8 is 1. 8 is not enough to subtract, so 8 will borrow, so that becomes 7. All right, the 0 here becomes 9 because 0 got nothing, so 0 got to borrow. The idea that 0 becomes 9 is 0 doesn't have anything to give to the 8, to the 7, excuse me. So that the 0 got to borrow from the 2. But once the 0 borrow from the 2, it's borrowing 10, so you got to give 1 away. You know what I'm saying? Because it's supposed to give 1 away to the 7. So that's why it becomes 9. You can think of like that. So got enough, let's subtract. So when the 7 borrow from the 0 becomes 17, you can say 17 minus 9, or for me, I would say 10 minus 9 plus 1, which is 8. 9 minus 4 is 5. 2 is not enough to subtract, so that becomes 1. Oh, sorry. 2 not, sorry, doesn't have to do that. 2 is not enough to subtract, so 2 got to borrow from the 8. 8 becomes 6. So that will be 12 minus 7, which is 5. All right, 6 doesn't have to subtract anything. That will be 6. So my answer is 655,815. So just kind of real quick refresh your memory on how to borrow. So don't borrow all the way to the beginning. I think students, started with the 0 cannot subtract 5. It borrow all the way back to the 8. No, not quite like that. You need to borrow. You need to borrow from the person that has it. Then you need to go back and start subtracting before before I start worrying about, okay, 8 cannot subtract. You know what I'm saying? 8 cannot subtract the 9, so I gotta borrow. Oh, maybe I made a mistake right here. 8 cannot subtract. 8 didn't. Oh yeah, 8 did not. It did not have enough to subtract the 9, so that should be 9 right here. Sorry about that. That should be a 9 right here. Yeah, because it's not 7 subtract. It's actually 18 subtract. Yeah. I don't know why I took one away. All right, let's take a look at multiplying whole numbers. Okay, very important. Multiplication table, your timetable is probably one of the most important things um, that that you could have learned when you were young. Okay, the more you memorize the timetable, the easier operation of integers, whole number, decimal becomes easier. Okay, we refer back to the timetable quite a bit in this class. So multiplication is basically come from a repeated addition. So 3 plus 3 plus 3 plus 3, something plays itself so many times, it's probably easier to we can actually write them as multiplication. So 3 add on to itself 9 times is the same thing as 3 times 9. So 3 times 9 is 27. We say the number 3 and the 9 are called factors of 27. And the 27 is called the product. Okay. The answer you get after you multiply is called the product. The answer you get after you add is called the sum. The answer you get after you subtract it is called the difference. All right. So we established, 3 and 9 are called factors, okay, of 27. 27 is the product. Now, so make sure you know your timetable. So let me refresh your memory as we go along the semester. Your memory will come back. So again, got to line them up by the place value. 366 times 15. So 5 times 6 is 30. Carry 3. 5 times 6, 30 again, plus 3 is 33. Carry 3 again. 5 times 3 is 15. 15 plus 3 is 18. All right, 1 times 6 is 6. We put below the 3 because now I'm multiplying my tens place, right? So I got to put under the tens place, not the ones. 1 times 6 is 6. 1 times 3 is 3. All right, multiplication, we will add them up. That will be 0, 9, 14, and 3, 4, 5. 673 times 186. Okay, the more you hear this, the easier it is. Okay, 6 times 3 is 18, carry 1. 6 times 7 is 42, plus 1 is 43, carry 4. 6 times 6 is 46, 46 plus 4, that would be 50. All right, 8 times 3 is 24, put below the tens place, the 4, carry 2. 8 times 7 is 56, plus 2, 58, carry 5. 8 times 6 is 48. 48 plus 5, we carry 53. All right, 1 times 3 is 3, 7, and 6. So we line them up by this place value. 8 times 3, 8 is in tens place, so we start with our product on the tens. 1 is in the hundreds place, so we begin to round answer on the hundreds. So that's 8, 8, 11. Okay, 3 plus 7 is 10. 10 plus 6 is 16. This is 12. There you go, 126, 188. All right, division. Okay, you got to know your timetable in order to do division correctly. All right. For example, 20 divided by 4 equal to 5. The 20 is called dividend. The number that you use it to divide somebody else is called dividend. And you got your divisor is 4. The answer is called the quotient. So I write it out in 3 different ways. The normal division, the normal long division, and write it as a fraction. So when we talk about fraction in other topic, the numerator is a dividend. The denominator is always a divisor. All right. A couple of property here. Division by 1. Any number divided by 1 is also that number itself. Okay. If you same number dividing each other will always be 1. And this can become 2 divided by 2 is equal to 1, for example. Or when we talk about fraction, numerator 2 times denominator half. See, inverse, right? 2 and half are inverse. When they multiply, the answer is also 1. So this is the same thing. Excuse me. Saying 2 divided by 2 equal to 1 is the same thing as saying 2 times a half. Okay, that's equal to 1. So you can say if I got $2, I'm going to divide my $2 by 2, everybody get $1. Or I can say if I got $2 and I give half of the way, I will end up with $1. Okay, either way you're saying it, mathematically it's the same answer. 0 divided by any number is 0. Very important that you understand. If I give you an example, 0 divided by 2, the dividend goes in the inside, divisor goes on the outside. 2 times what number will be 0? The answer is 0. That's why any number divided by, that's why 0 divided by any number is always 0. If I use 2 divided by 0, for example, write it out as a long division, put a 2 in the inside, divisor goes on the outside. Tell me 0 times what number up here will equal to 2? Well, the answer going to be nothing. 0 times nothing is equal to 2. So that's why any number divided by 2 is any number divided by 0 is undefined. Okay? Make sure you know the difference. Divisor cannot be 0. Okay? Or denominator cannot be 0. It will always be undefined. Now, I have a little trick when it comes to long division. I'm going to show you real quick. The way how I estimate. So 446, 74. The first thing we do is make sure we lined up correctly. 74 cannot go into 4. 74 cannot go into 44. 74 can go into 446. So the first quotient got to go on top of the 6. Okay, so now the question is, what number? Okay, some students start out with 74 times 2, 74 times 3. Sometimes that take a little bit too long. Instead, I'm going to start out with an approximation. I'm going to use my first number. First number is 7. 7. I know my first number 7 cannot go into the first 4. but my first 7 will go into 44 about how many times? Well, I know 7 times 7 is 49. Okay, so what about 7 times 6? 7 times 6 is about 46, so I'm going to try with 6 first. 6 times 4 is 24, carry 2. 6 times 7 is 42. 42 plus 2 is 42 plus 2 is 44. So so the 444 is smaller than my dividend. So I'm doing it right. So my remainder is 2. 6 remaining 2. Okay. Now what happened if 6 was too big down here? Then I will use 5. Okay. So rather than work your way up to the 6, then the way I'm doing it is approximately trying to find the largest number that may work. If that number doesn't work, then the number below it will work. All right, I'm try again. 581. Okay, 15539. I know 581 cannot go into 115, 155. You got to go into 1553. So that means my first quotient got to go on top of the 3. So the question is, okay, about how many times? Well, the way I estimate is by saying 5 will go into 15 about 3 times, right? So I'm going to try with 3 first. If 3 is to be too big of a product, then we'll use 2. 3 times 1 is 3. 3 times 8 is 24. Carry 2, right? 3 times 5 is 15 plus 2 is 17. That's too big. So 3 doesn't work. So I'm going to use 2. Okay, that's 2 times 1 is 2. 2 times 8 is 16. Carry 1. 2 times 5 is 10 plus 1 is 11. So that's 1, 9, 3. All right, because 5 got to borrow. So that'll be 15 minus 6. All right, so after I subtract, this number got to be smaller than my divisor. Bring down the 9. So try it again. 5 cannot go into 3 alone. So 5 can go into approximately 39. About how many times? Well, 5 times 8 is 40. So I'm going to use 7. 7 times 1 is 7. 7 times 8 is 56. Carry 5. 7 times 5 is 35. 35 plus 5 will be 40. That's too big. So 7 doesn't work. That means I got to use 6. 6 will work. 6 times 1 is 6. 6 times 8 is 48. Carry 4. 6 times 5 is 30 plus 4. 34. When I subtract, that is 3. This is 3. This is 4. So my answer, 26 remaining 433. All right, that's how we do this. So just a little different way to do it to kind of show you how to estimate what number you can use for quotient. Okay, rather than multiply your way up, you can actually try to estimate first and work your way down. All right, the power of tens, multiplying by the power of 10 is very important. Okay, a whole number multiplied by 10, all you got to do is add 1 0 to the right of the answer. Okay, multiply by 100, adding two zeros. Sorry about that. Adding 2 zeros to the right. This would be 3 zeros. Adding 3 zeros to the right. Okay, so what does that mean? Well, what that means is 800 times 60, I can simply say 8 times 60. 8 times 6 first, which is 48. All right. So I got how many zeros? 2 here, 1 here. So all I got to do is add 3 zeros to it. Okay, 3 0 you can see consider as 1,000. 811 times 200. So my final answer, I need to add 2 0 on the back. So this problem is basically now becomes 811 times 2. So we can say 2 times 1 is 2, 2 times 1 is 2, 2 times 8 is 16. That's how we can quickly come up with the answer. Now dividing is opposite. Rather than adding zeros, we can take away zeros. So the way how we take away 0 is go back, is cancel them out one by one. So 80 only had 1 0. 6400 had 2 zeros, so 1 canceled out with 1. So that means this problem just now becomes 640 divided by 8. So we know just by looking at it, we know 8 can go into 64 8 times. I got 1 0 remaining. So my answer is about 80. It's 80. Okay, so just a quick refresh of memory on how to add, subtract, multiply, and divide whole numbers and talk about and begin to introduce the properties of real number. Okay, that will conclude this video. Thank you for watching.